Hi everybody, we have this beautiful question. This is a rectangle given that ABCD is a rectangle and we are expected to find this distance MA. So I would like to request you all to pause the video and attempt the solution. Okay, so I hope you all have got the solution. So the requirement is we are expected to find MA, right? Now what I wish to do is foremost, let me just connect A with M or M with A. So I'm going to connect this. It's a straight line, right? So this entire thing is a diagonal. Now, having connected M with A, let me write that length to be as X. So we are expected to find X in short. What is the value of X? So having done that, the next step I wish to do is I would like to drop a perpendicular that runs through M. Okay, so that is all right. Now let me have this distance from M to say E as some Q, right? So distance from M to E as some Q. So this is a perpendicular. Now I would like to drop another perpendicular, say from this point F to M. So they're all perpendiculars and this is intersecting all the way to the other side. So this is a straight line, it's a perpendicular which is going through M. So having got that, let me just take this distance as some T. So this and this are equal. So this will also be equal to T. Now let me take this distance as some P, FA to be as some P. So this is P, the distance is P. Now I need to get X, right? Now this is 90 degree. I already mentioned to you it's ABCD is a rectangle. And so I am having a right triangle and I can use Pythagoras. So if I were to consider AMF or FMA, I can apply the Pythagoras law. So from Pythagoras theorem, I can rewrite this as, in terms of X, I wanted X, right? So X squared is equal to T squared plus P squared. Wonderful, I got that. So now I am going to draw some inferences. So what are those inferences? That's very critical. Now I have taken this distance as Q. If this is Q, this will also be Q, right? Now let me take MC as some B and MD as some A, and BM as some C, right? So now I can write T squared using Q and A. I can always do that. So this is a right triangle, right? So this is 90, this will also be 90. So if I were to write it, let me use this space. If I were to write it using the Pythagoras, this is going to be t squared plus q squared is equal to a squared. So from here, t squared is equal to a squared minus q squared. So I can substitute this. So I wish to take that. In place of t squared, I wish to write it as a squared negative q squared positive p squared. Okay, that is nice. So now I have to do another manipulation. So what is that manipulation? I have to actually get rid of this cube. So how am I going to do that? Now let us go back to the figure. Now if I were to take this distance, if you can clearly see, I have not marked this distance at all. Let me take this distance as r. Now if this is r, this will also be r. So if I were to take this point as g, mg will also be r. So let that be there. Now that looks okay for now. Now what I wish to do is, I'm not going to do anything with p squared now, but I would like to change this q squared. Now clearly you got a q here, you got a q here. I'm going to be utilizing this triangle, right? So let me use this part of the page. So from here, q squared plus r squared is equal to b squared. So q squared is equal to b squared negative r squared. So take this and substitute here. So this is equal to a squared negative of b squared negative r squared positive b squared, which is equal to a squared negative b squared positive r squared positive b squared. That is fine. Okay, now clearly you can see you got a r here and you got a r here. Now this distance is p, so this can be translated over here. So from here what I wish to do is I would like to replace r. Now if I were to consider this triangle, so this is going to be r squared plus b squared is equal to c squared. So from here r squared is equal to c squared minus p squared. So substituted here, this is going to be a squared negative b squared positive c squared negative p squared positive p squared. So clearly negative p squared positive p squared gets cancelled, giving me a squared positive c squared negative b squared. This is equal to x squared, but we need only x, so therefore x is equal to root of a squared positive c squared negative b squared. Now this can be taken as a formula, right, where you can have so many combinations, right? You can have values for a and b and ask for some other side. So many combinations of questions can be asked from this particular one diagram, and this is a beautiful formula. And what is x? X is nothing but MA, and that exactly the question's requirement, find MA. So thank you everybody, enjoy your night.